in 2017. What is the purpose of Evolved Laser Interferometer Space Antenna Project? Right? First option, first statement, to detect neutrinos, to detect, then second option, to detect gravitational waves, then to detect effectiveness of missile defense systems. Last is to study the effect of solar flares on communication systems. Right? So I think if you have studied the defense topic properly, you can eliminate this one. But then again, other three options are tricky and you need to know in order to arrive at the answer. So why LISA? Again, E means evolved, right? So this thing is the main technology. Why LISA? Because of gravitational waves. It is an experiment to detect the gravitational wave. It's a mission to test the technology for eLISA, LISA Pathfinder. That means the LISA Pathfinder was launched in 2015 and it's the mission which was used to prove the, or rather develop the technology for eLISA. So it's a big space project and they're usually planned well in advance. This mission is slated for 2034. Recently some approvals were given and it might start getting manufactured, or the manufacturing might start in 2025. Right? Now LISA Pathfinder was successful and also on Earth LIGO Observatory observed the gravitational waves. So because of this, the eLISA has been given a push. Now eLISA, what is this? It has 3 spacecrafts which will fly in a triangular path around the Earth. The arm length of each edge of this imaginary triangle will be around 50 million kilometers. So 3 spacecrafts will be like this. So one spacecraft will be here, one will be here, one will be here. So they will send lasers to each other, right? They are not physically connected to each other, but they are sending lasers and they will orbit around the sun behind the Earth. I mean, they will follow the Earth around the sun. Inside these spacecrafts, there will be free falling cubes, right? If these free falling cubes are hit by gravitational waves, then the change in the distance between these cubes will be accurately measured by laser interferometer, right? So you can see here, first come here, it will follow the Earth, right? This is the triangle. 3 spacecrafts will be following Earth around the sun in a triangular shape. Now, if the distance between these 3 change, so you can see the shapes are different, right? So 3 identical spacecrafts are placed. They will exchange laser beams. Now, gravitational waves will change the distance between the cubes in the spacecraft. Now, this change will be measured by these laser beams, which are red in color, right? As you can see here, free floating golden cubes will be inside the spacecraft. Okay, right? So what are the incorrect options? First, it is not there to detect neutrinos. They are detected by other specialized observatories like IceCube, which has also been asked by UPSC, and we have discussed that, right? Second, to detect the effectiveness of missile defense system. No, this is not related to eLISA, right? eLISA is only for astrophysical phenomena. Statement D, to study the effect of solar flares on our communication. Now, this is also not directly related to gravitational waves, hence it is not the purpose of eLISA. So why do we need to go to space for detecting gravitational waves? This is an important thing which you should understand. We'll discuss this briefly only. This configuration in the space allows extremely large detectors. See, the distance between these detectors is million of miles, million of kilometers. Now that cannot be done on the Earth. It can only be done on space. So the distance between the spacecraft is so huge that they cannot be placed inside the or on the Earth. So eLISA aims to measure gravitational waves in the frequency from 0.1 megahertz to about 100 megahertz. For this, it is necessary that the arms of the interferometer, that means the distance between the spacecraft, should be million of kilometers, right? Now this frequency right, is expected to be sensitive to a rich set of sources of gravitational waves. What are the features of LISA? Okay, not eLISA, LISA. Now, LISA has 3 spacecrafts that form equilateral triangle, right? So, from space, LISA can avoid noises from Earth. It will be far away from the Earth. As you can see in this diagram, it will be far away from the Earth. So, it will avoid the interference coming from Earth and other regions surrounding the Earth. Also, gravitational waves that LISA would discover would include ultra compact binaries, supermassive black holes, and extreme mass ratio in spirals. Now, many events like these, like merger of black holes, they swallow neutron stars, right? Big Bang also released gravitational waves. So many big events in the universe, they release gravitational waves. So what happens is, by detecting gravitational waves, we can prove theories like general relativity, and which has already been done. Now, what are gravitational waves? These are basically ripples in space-time and caused by violent and energetic processes in the universe, like merging of 2 black holes. Just imagine, black hole is super massive, right? And then they merge, 2 of them merge. So they release ripples. I hope you can see this. Like this, they release ripples, and this is detected by LISA. So a black hole, if it is sitting normally in the fabric of the space-time, it will just have a bend in the space-time. But if 2 black holes are revolving around each other, because they have massive gravity, so they attract each other, so they are now revolving, and slowly they will merge. So when things like black hole are accelerating, they create ripples. If they are still, they are just creating a bend in the space-time. That's all, right? So connecting the dots, you need to understand the gravitational waves in depth. This is also understood as reverse engineering, because you try to understand UPSC and what it can ask. Now, next point is previously installed laser interferometer gravitational wave observatory, LIGO. Then India's giant meter wave radio telescope, right? The answer is B. Answer is B. So we have understood LISA, we have understood gravitational waves, right? What else we have understood? Why we need